Okay, so this video is for geometry. We have a chapter 10-11 take-home test. And again, here's just an extended response question to help you with some things. Alright, so first here we have a net. And remember, a net is just a three-dimensional figure drawn in 2D. So you see that this net, it's called a composite space figure because there's multiple different types of polygons. So what figures make up the composite space figure? So that's a pretty simple question. So if you look to see, I think we're going to have one base. So one base is a hexagon. So you have one hexagonal base. And then the other faces, I guess we could call them all lateral faces. So it looks like we start with 1, 2, 3, 4, 5, 6 rectangles. So this is the semicolon. So we have 6 rectangles, and they're all congruent. So 6. And then it looks like at the top we have 6 congruent triangles. So I think of this as like maybe like a castle, like a column in a castle. You know, you have the base, and then you have the rectangles above, and then it comes to a tip-top point. So now I ask you, what is the surface area of this composite figure? So again, we don't really have a formula for this type of figure because it's not necessarily a prism or a pyramid. You know, it's very much a prism without the second base. Or you can think of it as the lateral area of a prism and then the surface area of a pyramid, a hexagonal pyramid. But anywho, we're going to find the area of these different polygons. So let's start with the base. All right, let's go big or go home. Here we go. So let's draw the picture of the hexagon. And this is great practice because you have the area of the hexagon problems. And what do I know? Well, this 4 centimeters is also the side length of the hexagon. I'm going to put it down here. So I am going to draw in my 2 radii. And again, area of a regular hexagon, or any regular polygon, 1/2 A and S. I need the apothem, the side length, and the number of sides. I know the number of sides is 6. I know the side length is 4. We're going after our apothem. So it requires the triangle. 360 divided by 6 is 60 degrees. And then when you draw in your apothem, you want half of that angle. So half of 60 is 30 degrees. And now I'll come over here and I'll draw the triangle right here. Let's do it here. There's my apothem. There's the bottom part of that side, and I'll do that dotted, there's your radius. So the angle I just found is that top angle, 30 degrees. This is your apothem, it's perpendicular. Now remember what the apothem does to the side length, it cuts it in half, so this is 2 centimeters. Okay? And now I want to find that apothem, so here's what I'll do in green. I'll circle the angle, label the 3 sides, hypotenuse, opposite, adjacent. Could care less about the hypotenuse, adjacent and opposite is tangent. Tangent of 30 degrees equals the opposite 2 over the adjacent A. Put it as a proportion, cross multiply A tangent of 30 degrees equals 2. Divide by the tangent of 30 degrees. And in my calculator, 2 divided by the tangent of 30, I get 3.46. So then what I'll do over here is I'll just put that in my formula. Area equals 1/2. 3.46 times the number of sides, which is 6, times the side length, which is 4. And it says rounded in your square centimeters, so no decimals. 0.5 times 3.46 times 6 times 4. I get 41.52. So that'll be 42 centimeters squared. Okay, next, so that's the hardest part. So now is the rectangles. So next, so the rectangles have a base of 4 and a height of 6. So here we go. So I'll do this in blue. So the rectangle is here, has a base of 4 and a height of 6. So area equals base times height. Area equals 4 times 6. Area is 24 centimeters squared. Now let's remember that there's going to be 6 of them, right? So let's keep that in mind. There's 6. And then in the same regard, we'll do the triangle. And now it gives us the triangle's height is 5, and if we bring this 4 up, that's the base. So each of these triangles has a, let me do a better drawing, sorry, has a height of 5 and a base of 4. So the area of a triangle is 1/2 base times height. The area of the triangle is 1/2 times 4 times 5. The area of this triangle is half of 20, which is 10, and that would be centimeters squared. But again, there are 6 of them. So what is the area total? Well, the surface area total equals the hexagon, 42, plus 6 24s for 6 rectangles, plus 6 times 10 for the triangles. So I'll just type it in my calculator all at once because it will do the multiplication first. And I get 246, and that would be centimeters squared. Okay, so there we go. That's a good extended response question, especially reviewing the area of a regular polygon. So best of luck on your summative assessment, and we'll see you next class.